All right, guys, welcome back here. So this time we're going to see how quickly we can run through the weapons and weapon systems here quick. So we'll start here with the laser gun. And we see we have in the prefab the gun itself and then a shoot origin. This is just the barrel of the gun where our bullets will be originating from. All of our weapons have a linked entity group in order to link up with the player character. It has a base weapon authoring component, which has where its origin is going to be, whether it's automatic, its fire rate, spread rate, projectiles per shot, and then the visual feedback, which is the recoil and the bob when you're running, and also the aiming. So it will focus in the field of view while you aim. This does not decrease the weapon spread. It should, but right now it's just visual. And some of the weapons, beyond being a base weapon, they are either like a Raycast projectile or like our plasma gun here. It'll be a prefab projectile. So the laser gun, it's a Raycast, so it's just going to cast a ray from what was actually from the center of the screen out in order to see what the target is hitting. The projectiles will shoot an actual game object entity out of the gun in order to do your damage. So the plasma gun shoots plasma, which has the plasma shot visual authoring component as well as the prefab projectile authoring component. Not entirely sure why they put the damage onto the shot visual component, but this is the one that is actually doing the damage. The projectile prefabs all have speed, gravity, lifetime, and then the visual offset correction. But that's for the stuff there. The plasma gun. The machine gun is also a Raycast, but its machine gun barrel visual, the barrel actually spins when you pull the trigger. The rocket, similar to the plasma, it has damage on its visual component, but it also has a damage radius. So here, anything within units, I guess that's meters, will also get splash damage. And then there is a radius damage. There is fall off. I think it's just in the system. It's specified there. The rocket projectiles don't have gravity to them, so they'll just fly in a straight line until they hit something. You could also have like a homing rockets and whatnot as well. Launcher and the shotgun. The shotgun is the only one that has multiple projectiles per shot. But it's going to shoot 24 bullets at a time with a spread of 10. Okay. So those are the weapons. We can start looking at some of the code here. So when we first spawn, and every time we spawn, we are setting an active weapon for the player character. And I think right now it's set up to be a random weapon every time you spawn. So this is going to set up a new weapon for you. Here in the active weapon system, this will be running first on the server and client. And basically what we're doing here is we are grabbing a weapon control lookup. So this is whether you're hitting the fire button or whether you've released it. We have a lookup for all of our first-person characters. Lookup for the shot simulation origin override. This will move the shot origin from the tip of your gun to your crosshair in the middle of the screen. So where you are looking at is where the Raycast will be coming from. Linked entity groups and the weapon shot ignored entity group. This is going to be your player character. So you're going to ignore your own entity while you are shooting, just so you don't accidentally run into your own bullets while you're running and gunning. So here, this is the setup job. So this is going to run only once. So as soon as we spawn, we are going to check the active entity, active weapon entity, and check it against the previous active weapon. When you first spawn, previous is going to be null. Basically, every time you spawn, previous is going to be null. So this is going to run. And then we look up our control group and we will see if we have a active weapon entity, which we will. We'll grab our first person character here, and then we'll set the shoot override origin to be the character view entity, which is your view entity is just where your camera is going to end up being, which is in your face. And then we'll set this to our lookup here. Then we're going to set the active weapon entity's parent to our weapon animation socket. This way, you just have to animate the weapon animation socket and then the gun will move accordingly. We give the weapon the new owner of ourselves. We'll link it to our character, so when our character disconnects, it all goes away as well. And then we'll add ourselves to the ignored entities list. Down here, they have a section that you would use if you are switching weapons. So here you would disable the current weapon, reset the owner, reset all the data, unparent it, basically the opposite of what we did up here. You would do this for your previous weapon. And then here at the very end, after we do everything, we set our previous entity to the current entity. So this does not run again. It's only going to run once until we change weapons or die. Okay, so we ran through a lot of the weapon component data on the actual prefab. This I don't think is doing anything special here. We have a Raycast weapon, prefab. The weapon projectile event, we'll go through this a little bit, but every time you shoot, we will add a weapon event to this buffer list. And this is just going to be for how we spawn our visuals and also our Raycast as well. So we have the ID of the event, the simulation position, which is what's on the server. The visual position will be what's on the client, and then our simulation direction, so where we're looking at on this from the server perspective here. For our Raycast visual projectile event, this will need a tick number for the client prediction. Since our clients will be running ahead of the server will need to know when to actually look up the collision data for the Raycast. Then we'll have whether it hit, the endpoint, and the hit normal. So these are for your hit effects. When they hit, we need to know where to spawn the hit sparks and whatnot. Now we have our active weapon component and the visual feedback. This is the weapon bob, recoil, aiming, the kick, and all that. Our weapon control. This is just whether we are shooting, when we've released, and whether right click, the aim is being held. Our owner and the origin override. All right, the weapon systems here at the top here has a couple of component system groups, and these are just collections of these groups, so you don't have to just save you a little bit of space, so you don't have to copy these over and over again. So we have our weapon prediction update group and the visual update group. The prediction update group runs on both the client and the server in the predicted simulation group. And on the visual group, this is just running on the client locally. All right, so in the weapon simulation system, we are going to be grabbing, in the update, we'll be grabbing the game resources, network time, and then we are passing these into we have a base simulation job, which will need the delta time, our local transform lookup, parent lookup, and the post-transform matrix lookup. Now, if this is the first time fully predicting a tick before rollback happens, then we'll do our Raycast simulation job and also the prefab simulation job if we have a prefab. And much the same way here, this time we are passing in whether this is on the server or not, the oldest allowed tick request. So if it's too old, the Raycast will get ignored. Our network time, our physics world, the physics world history, which is where some of the rollback happens. We'll need to know however many, I think it's 16 frames in the past, or I guess 16 ticks. It's as far as it goes right now. Then we have our Raycast projectile lookup and our health. The Raycast health, Raycast weapons do the health adjustments in its job here. The prefab weapons is a bit simpler because all it is doing is just spawning the prefab projectile. All right. So down in the base weapon simulation job, here we are getting all of the base weapon control, the weapon projectile event buffer, and also the weapon shot simulation origin. Here we clear the projectile events, have our total shot counts, which will be 0 at first. And then if our weapon control has shoot pressed, then we'll set the base weapon firing to be equal to true. Handle the fire rate. And this is the delays between shots. We clamp the shot timer just so we aren't constantly updating the shot timer here. This is a ghost component with a ghost field, so any updates to this will automatically get broadcast out to everybody. So here, as long as we are still shooting and our shot timer is more than the delay between shots, then we just add to the total shot count. And then if we shot, then we will decrease the shot timer again to do this all over again. If we're not an automatic weapon, then we only want to fire once regardless. So we just automatically turn firing to false. So here, if we are not automatic or we've let go of our shoot button, we'll turn firing to false. All right, so how we changed our total shot count here. We have our shots to fire, our previous shot counts, which will be 0 at first. And then here is where we will start to actually calculate where our shots are going. We have a weapons utility class here that will, let's see if we can here. So this is basically shooting the raycast from the middle of the screen instead of from where your weapon is, just for a little bit more visual accuracy. And basically this is doing just some fancy math to get our middle of our screen for the crosshairs. So here we'll loop through all of our shots to fire. We will add to our total projectile count. Here we have random Unity mathematics.random, which is different from the Unity engine.random you might be used to. This is for the mathematics class here that has a lot more deterministic functions to it. So this will create this random create from index. This will always create the same random number according to this index. And this is important for when you are doing rollback and also for your other clients. All the clients need to shoot in the same direction. So for each projectile, we need to be in the same space. So for our shotgun that has 24 shots or projectiles per shot, we need all of those going in the same direction. So there we will use create from index. We also have our rotation spread, do the same thing. And then we add this projectile event to our list of projectile events. This is the math to do the calculate spread rotation. Here is just doing math slurp with our random next quaternion rotation. For our spread radians, this is the base weapon dot spread. So here in the Raycast job, we are grabbing the network time, the physics world, the physics world history singleton, and we're looking up all of the Raycast projectiles and all of our health components. We also have a list of Raycast hits. So first we'll check our projectile lookup table here to see if we have any Raycast projectiles. If we do, then we grab our collision world from the physics world history from tick, which is the server tick that work. All right, so this part right here, this is just in the editor, and this is basically just checking if our delay is less than 0, if it's like -1 for some reason, that's an invalid time. So something went wrong there. And then if our expected tick is not the return tick, then that usually will mean that you're trying to compensate too far back. And right now, I believe this is here that the history size right now is 16, and eventually they want to increase that to 32 once it's available. Apparently, there is a thread about this. I haven't actually read the thread yet. Anyways, so here we are going to be looping through all of our weapon projectile events. Here we have another utilities class or calculate individual Raycast shot. So here for each Raycast, we are going to create a new Raycast input, which has a start, an end, and a filter. Right now it's just the default filter. We call our collision world.cast ray, give it the input, we'll get out our hits, which would be here for our hits. Same for our hit found here. We have another get closest valid Raycast hit, because this will return everything in our line of sight that gets hit. So maybe you have a sniper rifle that is going through multiple targets. You might want to choose more than the first or closest hit. And this is up here. And this is just doing a sort for closest entity here. And here we have our range. We got hit. Then what you will do is we'll grab the closest hit dot fraction, which is the percentage, the fraction of the distance of the entire Raycast that got hit. We'll multiply that by our range to get our hit distance. This will be used for damage scaling, I believe. We also have the hit normal and the actual entity that got hit. This will be for spawning our hit sparks and hit effects. And then we'll just return the shot endpoint as well. So here we will add the visual projectile events. We're going to add our tick, whether it got hit or not, which instead of using a bool, it's using a byte. I think is slightly more efficient than a bool. Our endpoint, and then our hit normal. And then here for any effects that are too old, we'll just go ahead and clear them out. And that's basically if, a packet got dropped or something like that. Okay, and then here at the very end, we are going to be applying our damage to what we hit. And this is just getting the health lookup table here. We'll get our hit entity and grab the health component from it. And then we just apply the Raycast projectile damage to the current health. And then we save that health back out to our health lookup table. Here at the end, we have the on chunk begin, on chunk end. This is for the chunk job. And I believe that's just for allocating the native list. And I believe on chunk end automatically deallocates it. Okay. And then the prefab weapon simulation here. And all we're doing here is we are grabbing the prefab projectile from our lookup. And then for each of the projectile events that we had, we're going to spawn our projectile. And this is just going to instantiate it. We're going to set its position and rotation. and it's up vector. We'll set the projectile spawn ID. This is for predicted spawning. So this can run on the clients. Client can spawn its own objects, and then it will send that to the server, and then the server will also tell the other clients to spawn an object as well. To sync up all of these, you need the projectile ID in order to get those synced up to where they're all the same location. Here we are setting our ignored entities onto our spawn projectile. The same reason of the Raycast. We just don't want to accidentally hit ourselves. We're going to set the velocity and the visual offset, and also we'll set all that to the spawned projectile. And then on the server side, we need to set the ghost owner of our projectile to ourselves. The rest of this, I believe, is just initialization stuff. This last is base weapon shot visuals. This is setting our recoil strength and also the recoil FOV kick. So every time you shoot, the gun will pop back a little bit and the camera FOV will change a little bit. Okay, for the projectiles, the Raycast projectiles have a damage and a range. Yeah, we went through the Raycast visuals. These component data does have some functions to them, just little helpers. We have a projectile ID. Yep. Okay, and the projectile system. Here we are getting the delta time, physics world, the delayed despawn lookup. This will just be for despawning the actual projectile whenever it gets hit or its lifetime is up. We just set this to true, it'll despawn. So here we're going through all of our projectiles, and we check if they've already hit anything. If they haven't, then we will move them. Basically, this is just applying gravity first, then its speed, and then if it's the first time fully predicting tick, we check if it hit anything. So we just raycast out its displacement. So we just raycast forward however much it moved that frame, and then we just check and see if that hit anything. Here we are moving the local position, its position plus the displacement, and we count its lifetime timer up. And then the server will then despawn it when its lifetime is up. Or if, here again, we have initialization again. Okay. So here below is our Raycast weapon projectile visuals. And these are just basically your muzzle flashes that'll be coming off of the Raycast weapon. So here, if you remember, we had on our Raycast weapon, we have this visual sync mode, precise or bandwidth efficient. Here, if it is in the efficient mode, we're just going to create some temporary projectile visual events. and not actually send anything over the network. For most of our objects or weapons, they are going to be precise because we are going to want to know one for our our laser here. It's just one, and we do want this to be synced across the network to exactly the way it is. For our machine gun, though, that is going to be bandwidth efficient here, just because it's 80 shots per second, and even though it is just one projectile per shot, it's going to be a lot of raycast to actually send across the network, which doesn't ultimately matter really. So if we're in bandwidth efficient mode, here we are going to check whether our last visual total projectiles count is less than our total projectiles count. Up the Raycast projectile, get the shot simulation origin, and then we'll loop through our projectiles, calculate the spread, do all those things again, calculate the individual ray shots, and then add it to the visual effects here. So here we are going to actually process the visual projectile events, and this is basically going to be translating it back to the actual shot origin compared to where it was fired off from. And then here we loop through the visual projectile events. If the visual projectile event dot tick greater than our Raycast last processed projectile visual event tick, then we'll instantiate our projectile prefab here, set the components to it, position, rotation, all of that good stuff. Then here in the Raycast visual projectiles, we'll add all the things to it. And then here, if we're in efficient mode, then we clear out all of the projectile events, just so they don't get sent out over the network. So here in our prefab projectile visual system, this is just going to be spawning our projectile, and this will, it says up here at the top, it's just offsetting the projectile visual renderer so that it looks like it's coming out of the weapon instead of down the center of the camera. And then it lerps basically to be in the center of the camera. So this classification system, this is what handles the predicted spawning from the clients to the server. So we have this ghost spawn queue, which is the list of ghosts that the server is telling the clients to spawn. And then there is the predicted ghost spawn list, which is the objects that the client is telling the server to spawn. So how this works, we have our ghost spawn buffer here, which is our ghost to spawn. We have a snapshot data buffer here. And then we are going to look up from the snapshot data lookup. We get the ghost type. At least we attempt to get the projectile spawn ID from this snapshot buffer. This projectile spawn ID is one that we created back on the weapon system. here in this. So we will loop through all of the ghost to spawn list, and then we check whether the spawn type of the new ghost to spawn is the same as the projectile ID that we had set before. If they're the same, then we basically swap them. So if the ghost type of the new ghost to spawn is the same as the predicted ghost spawn, which is the one that we've already made, then we'll set the predicted ghost ID to be our predicted ghost entity here. And then we check if the ID is the same, the spawn ID is the same, then we'll just assign the new ghost spawn type predicted spawn entity to be the predicted local ghost spawn entity. And then we can remove it from our predicted spawn list. All right, so let's look at some of the actual visuals here for our rocket. Here, this is going to be where we despawn our rocket when it hits something, and also apply our damage to whatever it actually hit. So here we're going to have the health lookup, our despawn lookup, we got our hits list, and then if we're on the server, we're going to check if we've already processed the hit simulation and the projectile has already hit something. We need to apply direct damage to it, whatever we just hit. So this is just going to take our current health, minus it with the direct hit damage, and then apply it back up table. For everything else, we are going to cast a overlap sphere at the location into the damage radius, and then everything that gets hit here is also going to take damage according to its fall off, which is just going to be the maximum radius damage divided by the distance of the damage radius. Subtract the current health and then add it back to the health lookup. At this point, we can set the delayed despawn to true there. Okay, the rest of this is just the visual effects system on the client. Here, we are just creating the VFX request and then adding it to our plasma shot is doing much the same here, as long as we have not processed the hit simulation, projectile has hit something, then all we need to do here is apply our damage and then set the despawn delay component to true. And then here we set the VFX setting, VFX hit requests. And that is it. I guess we could look at for our machine gun barrel, we are just spinning the barrel here with rotation. Okay. I think that is really about it for real. So yeah, if you guys have any questions regarding this competitive template, just drop a comment below. Join us on the Discord. We're going to be participating in Global Game Jam at the end of the month. So I'm not sure what we'll end up doing there, but we'll be streaming that on Twitch and uploading it up to YouTube. So yeah, that's going to be it for now, and we will see you next time.